Okay, so what we're going to do is we're going to talk first about, if I can get this little window to go away. First, we're going to talk about a little bit of recap from week 4, because I got a couple of really good questions on some of the quiz problems. So I thought I'd go over those and just make sure that it makes sense to everybody. And then what we'll do is we'll dive into week 5. If you guys came across these questions, the ones regarding Harry Potter, you might have kind of, for the most part, it looks like people did okay. You can kind of see like the spread here that for the most part, the answers were pretty good. But anyways, it's a little tricky. There was 2 of these questions on the prequels and films in Harry Potter. And really it gets kind of, it's there to kind of test, working through the logic that you see, which if you ever take a certification exam, they do that a lot. They'll say, here's a query, what's the outcome? Or, like, what does this do? Or is it true that it does this? Or, something along those lines. And so this is a very common practice. You might even see it in some interviews and stuff like that. So it is a good skill to have, to not only know that like, oh, hey, I can write this, but also like, oh, if I look at a query, I can understand what it does. So real quick, just wanted to talk about this one in particular. So let's see, this one returns, let's start with the smaller one. So this one says, examining the following query, it returns films with prequels and films without prequels in the Harry Potter series. So it returns films with prequels and films without prequels. So what I always like to do is I like to have my handy Venn diagram, which I don't really have here. So I might try to draw one off to the side here. So bear with me. This is going to get ugly real fast. So I'm going to start off with my Venn diagram here, because whenever we do joins, this is what we do. So the first one is film F. They're both film, but this one, the other side is a prequel. So I'm just going to call it a prequel, just so we can kind of see what's making sense. And what we're doing is we're joining it on the prequel ID from the film is the film ID from the prequel. So basically, for context, if film, and I always like to kind of like go through a scenario. So if the film table, let's say we're examining Harry Potter and the Chamber of Secrets, I'll just put COS there. Harry Potter and the Chamber of Secrets has a prequel. So in this case, this film ID would be whatever. This is the title, and the prequel ID, which we have in the table, would point to Sorcerer's Stone. So that's our foreign key. So yada, yada, here's our record. And again, I'm sorry, I told you this was going to be ugly. So there's a record, a row in a table. It points to Sorcerer's Stone. So this is fine, left join. So we're getting all these, whether or not. And so what's interesting is also in this, we would have Sorcerer's Stone. And Sorcerer's Stone would also be included in here. So like if we're looking at this would be null for our prequel ID, but Chamber of Secrets would have one. So I'm just going to put X there that points to Chamber of Secrets. So in our Venn diagram, Chamber of Secrets would be right here in the middle because it has a match, but Sorcerer's Stone would be over here, just based on the join. But let's look at our where clause, right? So based on this, let's say here's our join. Let's draw a little table over here. So this side is our prequel. So we're doing our little join here. Wow, that is just lovely. So here's our prequel. For film, Chamber of Secrets, this prequel will be, what's it called? Sorcerer's Stone. And this one would be null across the board. So all of Sorcerer's Stone stuff, the prequel for this one would be null because Sorcerer's Stone was the first one in the series, depending on how you look at canon, but that's what we're going to go with. So let's look at our where clause, because if none of the where clause was there, this answer would be true, right? Because we're pulling both the Sorcerer's Stone and the Chamber of Secrets, and this is where they try to get you. So if we look at the where clause, it says where f.series name is equal to Harry Potter, which, okay, yep. Film series is Harry Potter. Okay, we still have Chamber of Secrets and Sorcerer's Stone, but this is where it gets interesting. So, and the fp.series name is equal to Harry Potter. So this one, the series name would be HP. Let's put series name up here for that. But this one, because it didn't match, it's null. So this one, this where clause, all of a sudden excludes Sorcerer's Stone and anything in this category. So really, what this does is it does an inner join, which means that it only returns films with prequels. Thus, the answer is false. Does that make sense to everybody? Does that? Oh, go ahead. Does that not make sense to anybody? Okay, so just to recap, basically, if you just looked at the join, it's true, which I think is like where they're trying to kind of like the trickiness of it. But really, we can filter out, and honestly, like even when I was learning, I remember this being like a huge thing to remember. There was a few times when I was learning, I remember thinking like, why am I excluding all these rows? And it's because in my where clause, I was filtering on a column that was only available on the side that was not joining. So you got to be careful. Anytime you use a left or right join, you want to be careful that your where clauses can handle that. So for example, a good alternative would be to, let me clear these. Clear all drawings. There we go. So a good alternative would be like if I wanted to do a left join. So like, let's say we wanted all of the, let's see, all the films that select everything from film F, left join, rental R on f.film ID is equal to r.film ID. I mean, technically, I don't think that those like, I maybe rental does have one. But let's say I wanted to say where r dot date is greater than the 1st of January 2021. Based on this, just like our other one, this is going to exclude, like if the whole point of this is to say, oh, I want all the films, whether or not they've been rented, this is going to exclude all of those films. Like the left join is not worth anything at this point. You might as well just do an inner join. If you have a where clause that's filtering data on the right side, there is no point in doing a left join. But what you can do is you can say something like this. So let's say if it's null, we can say if null, then use cur date or something like that. And then that way, when it evaluates it, yeah, and I don't really have an r dot, I think it's rental date or something. There we go. Yeah, and it doesn't work because R doesn't have a film ID. But basically what we can do is we can use this if null statement to basically say, oh, if r dot rental date is null, use today's date instead, which would then be greater than this. And then we include it and we still see the null rental date. Okay, let's move on to the other one. So this one says, examining the following query, it returns only films with prequels. So only films with prequels. So I'm going to go through this one more time. Where's my little drawer? Let's do regular lines. Okay, so I'm going to draw my little Venn diagram here. And honestly, like, I know the Venn diagram thing's a little weird. During some of my certification exams, I actually, because they give you a little whiteboard, I actually would draw out my Venn diagrams like right there in this during the certification exam, because I knew that they were trying to be tricky, and so it just helped me visualize and keep myself straight. So okay, let's take a look here. So just like normal, so I kind of like to look at the select clause and kind of just see what they're getting. So they're getting the title, and then let's see, case when not film ID equals, and then fp.title. Okay, so basically this is getting the prequel title conditionally, if as long as it doesn't match. So let's take a look here. So we're getting, so film F is on the left, and then on the right is prequel. So there's our prequel, and we're doing a right join. So based on the join, and I'm going to change my color here. Based on the join, we are pulling all of this data over here because it's a right join. So we're getting all the prequels, or basically everything from the right side. Okay, so we get all the prequels. But there's an interesting thing to this. So that's based on our right join. But if we look at this, it says on f.prequel ID is equal to fp.film ID, which is the same one as before. And that would do it. But it also says or f.prequel ID is null. So this makes things a little bit more interesting, because basically it's going to match based on this. So this is before, but if the if f.prequel ID is null, it's going to include these as well. So it's also going to include those. And then let's check our where clause, where f.series name is equal to Harry Potter and fp.series name is equal to Harry Potter. This one actually includes everything, because now, because we're including all the stuff over here too, everything has a series name because we have all the records. Does that make sense to everybody? I can draw out a table if you'd like, but if no one needs it, then I won't, because it's kind of like the other one, but basically this is just a flip, but because of this or statement, we're also including all these, whether they match or not. Okay, let's clear those, and let's jump into week 5. Modules, that's what I'm looking for. All right, sets. Sets are, and apologies if this is duplicate from the announcement, but we talked about joins previously, and joins are how we add columns. I mean, and they adjust how many rows are in there just based on matching. But for the most part, the reason why we join data is to add columns. So we're adding columns, or I like to think about it, we're adding data horizontally. When we're working with sets, we're dealing with the vertical, because with sets, we're dealing with, are we adding rows? And just so you know, I put this disclaimer in the announcements. A lot of these operators aren't supported in Mysql, which is really unfortunate that they're left out. But as long as you know what they do, they're really not too crazy. And I wish that they would actually do this a little different, because I actually envision this, instead of having A and B, it's actually flipped. So it's vertical. So I like to picture it more like this. So there's that one, and there's that one. It's like 1 and 2. That's kind of how I like to think about it, just because really we're adding rows, and we'll go over that more here in just a little bit. But anyway, so this is a union, which is basically like adding rows. So I'm going to go through the same kind of exercise that I did in my announcement, because it's a good use case, I feel. So basically, if we wanted to send out Christmas cards, or let's say like a Christmas email, a business Christmas email or card, let's just say both. If we wanted to send out something to everybody, in our database, there's kind of like two kind of sets here that we might want. So if we take a look at our customer table, that might be where we want to kind of see some of that stuff. But also we might want to take a look at our employee data. So let's see where our employee data is, or staff, sorry, staff. Because we want to kind of include both staff and customers in this. Maybe we're just kind of sending out like a little like card, or something. But basically we want all of our customers and staff all in the same column, which can be problematic because a join is just going to, like I said, add columns, and we don't like, there's no match really between customer and staff. Like we want those in the same list. So how we achieve that is through set operators. So if I select the first name and last name from customer, I get their last name and first name. And I'm actually going to select everything else here real quick, just so I can kind of see everything here. So let's get their email address as well. Okay, so there's kind of like, if we wanted to send an email to all of our customers, that's kind of the data set we'd go for. But like I said, we also want to include our staff in this as well. So what we do is we say union all, and then we build another select statement. But this time we're going to select the first name, last name, and email from staff. And now you can see that we have, well, it worked, but let's add one more field here. So we're going to also say customer as type. And in this one, we're going to say staff as type. And now you can see that for every person, now we also have a type, and you can see that our two staff members are down here and our customers are up here. So that's really handy. Basically, you can kind of see that why I like to draw this vertically is because this one is our customer and this one is our staff. So customer and staff. Now, in this case, we don't have any overlap. So really, we're just getting customer and staff like this. There doesn't happen to be any overlap, but if there were, it would include it. Now, that's kind of the difference between union all and union. So for example, if I were to take out this, let's say we had a staff member who was also a customer. Based on that, we wouldn't pull the middle. It's going to exclude any duplicates, if that makes sense. So union all includes sides from both, even if there's duplicates. A union is going to remove the duplicates. So for example, if I had Frodo Baggins, who is a customer, and Frodo Baggins, who is a staff member, with a union, he's only going to show once. With a union all, he's going to show twice. Does that make sense to everybody? Union versus union all?
Yeah.
Perfect. Okay, let's keep moving here. So union versus union all, got it. Intersect is really interesting too. And an intersect is just finding the ones that are duplicated. So for that same example, if Frodo Baggins is a customer and a staff member, if we changed our query to say intersect, which isn't supported, the intersection of that is going to be the ones who are in both. So if we change this to intersect, Frodo Baggins is going to be the only one who appears in the result set. So let's keep going. So except, again, except I don't think is supported either. Let's just make sure. Yes, so it is not supported. So except is going to find all the ones that aren't there. So for example, again, back to our Frodo Baggins theory, Frodo Baggins is the one that's in the middle if he's both a customer and a staff member. So if we use except, we're going to get everybody except Frodo Baggins. So Frodo Baggins won't even be in the result set, because in this case, we're getting customers who aren't staff members. And you know, I used to always think like, why would you use this? But there's a couple good scenarios, and I'll try to build one here. So imagine like you're trying to deal with like, you know, college classes. This is all relevant here. And let's say you want to find the students who have taken, you know, one class, but not the other, right? Or who have taken both classes. So let's say that CIT 111 is A, you know, select all the people who have taken CIT 111, and then B is select all the people who have taken CIT 225. And this is a good scenario because some people only take 225, some people take only 111, and some people take both. So in that scenario, let's say we just want to find the people who have still yet to take CIT 225. We could get that by just saying, you know, with this except. So I want all the people who have taken CIT 111, but exclude all the people who have taken CIT 225. So that's a really quick way to kind of like compare two data sets, even if it's almost the same. So like we could be pulling from the same table, but like, oh, I just want to kind of bin people in certain buckets. So it's really handy. And especially because it's all built just on two queries. It's not really like a join. It's just like, oh, get this list of people, get this list of people. How do I compare this list? You know, what are the ones that are only in this side? What are the ones only in this side? And what are the ones that are the same? And again, same thing here. So this one's just a little bit different. This data set is all of A and B without the overlapping region. This would be written as A union B except A intersect B. So you can kind of see how like this could get a little tricky, like a little crazy, because basically you can combine these. So, you know, we can say, oh, I want both A and B, right? So, and because it's a union, it's going to exclude the joins, and then we exclude the intersection. All right. If we tried to combine these two tables using the union operator, what would happen? And let's take a look. So basically, the big part of the union operator is that the columns have to be the same. Or the data type, sorry. So the columns have to be the same.
I'm sorry, Brother Tanner.
Yeah.
Are you referring to the slides? Because I'm just seeing the SQL program and not the slides. I don't know if are you referring to the slides?
Oh yes, I was referring to the slides, but I don't know why it's
okay.
Yeah, thank you. But now we're back in the SQL. It might have been because it still had like the annotation screen up, so that might have been why.
Okay.
But the important thing about doing joins is it really doesn't matter what your column names are. What really matters is data types. So for example, I could, let's say I made a mistake and I put email here and last name here with a union. So this is still going to work, but you'll notice that all of a sudden now I have like some all have some weird stuff going on. So in the last name field, you'll notice that it has their email, and this one has their last name. So it doesn't care about the name of the column. All it cares about is the order and the data type. So if I were to try to put, instead of email, let's put a staff ID. This one's actually gonna work because it's casting it. Let's try something a little bit more rough. Like for example, let's change this to customer ID.
A date, maybe? Or...
Yeah, date would probably cast as a string too, because basically it's trying to be smart and say like, oh, I can take
okay.
and turn it into a string. But one thing you can't do is take a string and turn it into a number. You know, you can't put a in an integer. So what I'll do here is I'll put so under customer, let's put last name here. Let's fix this. So this time it should throw an error because basically the first one in our list is kind of the parent or the one that drives it. Oh wow, and it actually worked. Let's see what happens down here. Okay, so it must be being smart. So it is going to actually try to make a so this field now becomes a varchar column. So basically it's probably got a setting on that's saying use the most compatible data type, which not all database systems do this. So this is actually kind of cool. So basically what it's doing is it's saying, hey, use the most compatible data type between these two. And let me actually see, because there's probably a way to turn that off. MySQL union force data type. Let's see. Anyways, there's probably a flag somewhere where it's doing that to basically say, or is customer ID a, let's see what this one is, not that. Let's get our table settings, customer ID is an int. Yeah, so it's casting those as a varchar essentially. Let's try, so customer ID, let's try a, yeah, so it is casting them. So basically it's going to try to use the most compatible data type, but for the most part, when you're putting these in there, you want to make sure they're the same. So that way it doesn't cause any problems. And let's actually try a, what is in staff here? Let's try a date. It should, I think it should cast it, but maybe it's going to be more picky. Oh, it casts it. Okay, interesting. So normally you would want to cast those manually. I'm actually surprised it does this because most of the time you actually want this. Sometimes it's helpful for it to automatically cast the data type because let's say that customer ID in this table is a varchar, but in this one it's an int. You know, it's nice that it does that for you, but sometimes you actually want it to throw an error because that way it's like, oh, you can't put a date in the email field, for example. But anyways, that's set operators. And that's actually, for the most part, kind of what I had planned for today. It's kind of a lighter week because really we're kind of ongoing with our final projects. Set operators aren't too terribly complex. One thing I will say is in like the quizzes and stuff, it may ask you about like intersect and accept and some of those, and just so you know, they're not going to work on your MySQL. So if you go to try those, just know that they're not going to work because they're not supported, which is really unfortunate. So just know, like, if it fails, don't just mark false, you know, or like just basically think through it, draw your Venn diagrams and go from there. In that vein, just so you know, I know I've talked about this before, but we use MySQL in the class because it's the easiest to kind of get up and going, and it's free. Free is also a big deal as to why we use it. There's others like Postgres that's free as well, but the setup isn't quite as easy. So that's kind of the why. But the reason, so that's why we use it. It doesn't support it, and it may be my opinion on as to why they don't support some of these other set operators is because MySQL is owned and maintained by Oracle, and Oracle also has their own database product that is a paid proprietary piece of software. And so my theory is that they just don't want to give you, MySQL is amazing, but they leave out certain things so that way it's not, well, why would I ever use Oracle if I have MySQL for free? Just my opinion, but just so you understand the reason why it's not supported, that might give context as to why. If you want to try it though, Postgres does support it and it's free. But anyways, a little bit of a tangent there. But like I said, this is kind of like all I had as far as what needed to be done. So at this point, I'm going to kind of turn it over. If anyone has any questions, anyone wants to see something in particular, anyone has any questions about final project stuff, but otherwise we can get out of here a little early if you'd like as well. So anyways, does anyone have any questions or anything they'd like to see? And if it's like real specific, what I'll have you do is maybe ask a question and we might save it for after recording if it's like really particular to your project. But if it's something that like, oh, this will benefit other people as well, then we'll leave it in. But does anyone have anything they'd like to see or any questions?
Yeah, I think I have like a quick question
Okay.
about the project because I was like building my relationship diagram for my project, and when I try to make a relationship between two tables, a relationship for many to many, like SQL asked me to create an intermediate table, basically, like to.
Yep.
Yeah, I think it makes sense, but it's like a table to link those two tables. And the project says that we must use at least 12 tables, if I'm not wrong, to build this project. So I'm just wondering if can I count those like linking tables in the number of tables that I'm gonna use or
Yep.
not?
Yep, absolutely. Yep, absolutely. And I guess as a good example, because I think I help someone who's building a database. Their final project is for Magic the Gathering. So that's the freshest example in my mind. But basically, those intermediate tables, what they're for. So let me pull out my lovely annotations here again. So what those are for. So we all know like card decks, right? Like those playing card games, whether it's Hearthstone or Magic or all those kinds of things. And basically the reason why it wants you to build that intermediate table is because one-to-one or many-to-many relationships aren't first normal form. So they're not first normal form, which means that it's not like a good relationship. It can get really messy when you start to like actually write your queries. And even though overall we end up with the same result, we want that intermediate table because it keeps a one-to-many relationship, which is first normal form. So for example, if we have cards, right, like imagine your favorite card, whether it's a Pokemon card, a Hearthstone or whatever, imagine those, but then we also have a deck. And let's just say, because I get this might be different, but let's just say that, a specific deck, that you buy from the store, like maybe they're like a certain set or whatever, a card could be in multiple decks and a deck could contain multiple cards. And so, really this is a many-to-many relationship. And yes, we can define those in databases, but like I said, they're not first normal form. And so we kind of want to avoid those at all costs for the most part. So what we do instead, just like you said, it had you create an intermediate table. And actually, I'm going to rename this so it just makes a little bit more sense. I'm going to call this a deck card. So we come up with this intermediate table. And basically what this is going to have, it's going to have its primary key, which is just a, a deck card ID, but it's also going to have a deck ID. It's a foreign key to here. And it's going to have a card ID, which is a foreign key to here.
So basically, like this specific intermediate deck table is like we were talking about only one specific deck with specific cards is what that means.
Yeah, well, basically what this is meaning is that a deck can have multiple, a deck has many cards.
Yeah.
But it can only, it basically, let's say that I have, like, I'm just going to use Pokemon, for example. Let's say I have a Sapphire deck, right? And like, I'm just completely pulling this out of the air. I do not know Pokemon that well. So let's say I have two decks, Diamond and Sapphire. And let's say that, like there's like a couple Pokemon that are unique to each of these. So like, let's say Pikachu only comes in Sapphire, and Charizard only comes in Diamond. But let's say there's a bunch of these like little grunt Pokemon that aren't worth anything, right? They're just like your normal cards, like Squirtle, right? I think Squirtle's actually pretty cool. I only know like a few Pokemon names, so pardon if you're a Squirtle fan.
200% more than the rest of us do.
So let's say Squirtle comes in both packs, right? So it's in Sapphire and in Diamond, and that really got messy. Let me make those a different color. So Squirtle is in Sapphire and in Diamond. So really it's a many-to-many relationship as to, like, oh, the deck has, Pikachu, like a Diamond has Charizard and Squirtle, a Sapphire has Pikachu and Squirtle. So it's a many-to-many relationship, but basically instead of building an actually many-to-many relationship, what we do is we build a one-to-many relationship this way and a one-to-many relationship this way. And then that way, like if we, because a card can be in multiple decks and a deck can have multiple cards, and this table is going to keep track of what cards are in what decks. And that way, like, all these things only exist once here. These things only exist once here. And basically the lines themselves are actually what's in the deck card. And then what's really cool about it is then all of a sudden we have this ability to actually have metadata about the connection between the two. So let's say from 2001 to 2010, Pikachu was in the Sapphire deck, like we have up here. But let's say all of a sudden he's also in the Diamond deck, right? So along with our normal foreign key stuff, we could also add a start date and an end date. Then that way, not only can we track which cards are in which deck, but we can have a historical record as that changes. Where if you just had a many-to-many relationship, that's not possible. Does that make sense?
Yeah, but just one question more, because I suppose this like deck intermediate table has a specific deck ID, right? That is is a foreign key from the deck table, right?
Correct. Yep.
It is the same foreign key. Okay, and I have the card ID, but okay, yeah, I don't know why I was imagining that like I needed like a new specific primary key for this specific table, for this new table that is linking the things, but not, right? It's like I just need the primary key of card and deck together, but I don't need to create like a new primary key for this new table, right?
And that is my answer is yes. So I always like to have a primary key. Technically, and this is where some business logic and complexities can happen. So I'm a big fan of always have a primary key.
Okay.
And the reason being is just so if you ever need to me, it's more utility. So like if you ever want to say like, oh, I need to delete this record, because there's nothing here that says that we can't have a card twice in a single deck. We could duplicate multiple cards. So like let's say that there's two buff cards in a deck, right? So let's say there's two of the same card in a deck. This model would allow for that. And so basically the only way to uniquely identify those different records is with a primary key. So that's kind of why I say that. But where it comes into business logic is, let's say you say, oh, a card can only be in a deck like one time, no duplicate cards in a deck. If that's the case, you could technically make this the primary key in combined. But again, like to me, that's like yucky. And this is like personal
Okay.
preference because it's not clear. So to me, like every table has the primary key, and then I build the table from there. Even though it's not necessarily necessary, it's more of a utility clean type thing for me.
Yeah, to like a best practice.
Yep, exactly.
Okay.
So would your
and-
deck card have the primary key in that deck card column? Would that be just a number?
Sorry, say that one more time.
The primary key in your deck card there, and then the middle one there,
Yep.
is that going to be an ID, just a number?
Yep. Basically, like any smaller databases, I always just use an integer as my primary keys. If I know that this thing's going to balloon, or if it's already big, then you might use something like a varchar to actually build like a UUID. And a lot of databases have UUIDs as like a specific data type, where it's like, instead of it being a number, because the alphabet just provides so much more values. Like if you know you're going to go over the limits of what an integer data type can hold, you want to go there. But for the most part, like for what we're doing here, I just set all my primary keys to integers.
Thanks.
Yep. And then that way, like that way you can say like, oh, if I need to delete this card that's in this deck, I can say, delete from deck card, where deck card ID is equal to 1001 or something like that. And then to answer your second original question, do these count towards your table count? And the answer is absolutely yes. Yes, they do. And just so you know, it says 12. I'm okay with 10. So 10, 12, like as long as you're in that ballpark. Which, for the most part, like, as you build all this out, like, these intermediate tables, you'll have a couple of those depending on your model. And so, yeah, if you're short on tables, let me know, because I can take your model, look at your model, and we can add some more, add some like really simple, like additional tables that are really low lift as far as like effort to add them, and then you meet the requirement.
Oh, okay, yeah, I like it. And just one quick question more.
Yep.
Just came to my mind. I was trying to find like I'm creating like the music catalog of a specific artist, and I'm storing like the cover of the album with the URL of the picture or the image of the album. But I was wondering like what is the best data type to store a URL? I read that we can use text or bar chart, but I'm not really sure what will be like the difference in a case like that.
Yeah, so really the difference comes down to between text and varchar. Varchar can hold, can you guys see my browser?
No.
Okay,
Nope.
let me pull up a different one and see if that works. And it might be because of that. All right, can you see Chrome by any chance?
Yeah.
Yes.
Okay.
Yes.
Perfect. I think it's when I annotate, like it sticks on whatever I was annotating on, which makes sense. So let's go to MySQL data types. So basically, as you're choosing what data types, really the one thing you gotta think about is just, what is, and you kind of want to future proof it, but like, what's the max kind of size I ever expect out of this? And the nice thing is it's I would lean on the edge of going small, because you can always go big. You can always change the data type and go bigger as long as it's bigger and of the same kind of like compatible type. So let's take a look at, let's see, char yada yada. That's not the page I was looking for.
Because I read on the internet that like text is the most popular data type that some people used to, but some people use, but I just was wondering if I know maybe text can like store more characters than bar chart, but I don't know if that is a good practice to use text for every URL that I want to use, and if a big practice maybe to reduce like space on memory using something smaller.
Yeah, and I guess that depends. So like if you're storing like album artwork, so like let's say all of your album artwork is going to be a shorter URL. So like let's say it's like like let's say it's just something small. Like let's say you're storing your own albums and it's under like fake music catalog.com/artist/Coldplay/images/ so like let's say that all of your images are going to like have like a similar format. In this case, I would say go with a varchar, because you're not ever going to exceed the limit. So just like a varchar can contain, it's a variable length in characters can be 0 to 65,535. So that's quite a bit of headroom. And really like, I would say probably like fix it at like 250. So like varchar 250, if it's going to be something kind of uniform like this. But if you're pulling images from all across the web and it might have like some crazy parameters, like, we've seen URLs that are huge. In that case, I would go with a text, just because then it can hold a lot more data.
Okay. Yeah, makes sense.
The only thing, so the reason why not just use text everywhere is because text, even though you're not using it, so like let's say you have 100 rows in your table, basically the database is allocating all that room anyways, because that could change at any point, and it could use all of it. So basically for every row, it kind of reserves that much space, if that makes sense. So that's why when it comes to data types, we always kind of want to like lean to like being more conservative, because like, let's say we end up with a trillion records, that's a substantial amount of data that's just unusable, or a lot of storage space that's just basically wasted. So that's why we always try to lean on the side of like, okay, just keep it to what you need, if that makes sense.
Yeah, great. Thanks.
Yep. Yeah, great questions. Any other questions?
I have a couple questions.
Okay.
Okay, first, I was wondering, since you pointed out that the text can hold a lot more than the varchar, what's the difference between 65,535 characters and 65,535 bytes?
So bytes is,
And after that, I have a real question.
yeah. So basically a byte, a character is usually like 8 bytes.
Okay.
And so this one actually, so like this varchar, I think they're actually, so this column length in characters, how many bytes per character?
Sorry, it's sort of a tangent, but I was like, wait, if it's so much longer, I don't know those differences.
Yeah, so this is kind of where it comes down to like what character set you're using. So like an ASCII character in 8-bit, so if you're using like UTF-8, is
Mhm.
1 byte. So that's probably why that's a 1-to-1. So basically any
Okay.
ASCII or UTF is, yeah, so UTF is between 8 bits. So this one varies. So if we're using UTF-8, it depends. So that's why
Okay.
it's like, okay, you know, depending on what data you have in there, it can change. So yeah.
Okay, cool. Thank you. Also, my real question about the project and the data tables was, so I'm kind of struggling to understand or know how and where to break up my things into tables. Like, how do you know where one table should stop and then another one should start and then they should be connected? Does that make sense? Maybe.
Yes, that's a great question. And basically what I would say is start with like just like a piece of paper and just draw bubbles.
Okay.
And kind of what I like to do, what's easiest for me is I like to kind of mind map, but just like you said, like where do we separate things? And to me, like that's like the key wording is we want to separate out things. So like for example, like what's your project?
I wanted to make a project management table or database, like Trello, or you know, I don't know, there's a few different types online, but basically like, you know, putting in a thing that needs to get done, and so then it's like has, you know, start dates, end dates, goal dates, like different users on there, different like subsets of tasks.
Yep.
Yeah, and it
So-
can get bigger, but that's the gist.
Yep. So this is kind of like where I like to start. So I kind of think like, what are all the different things or components to the project? So like, I always like to start with kind of the root one, like, which is a task, like you said. You know, and tasks are probably owned by teams, but we also might have like projects as a way to kind of like lump these. And you know, maybe we want kind of a hierarchy. And so like this one, and again, like you can make these as complicated or as simple as you want, because if we were really like, the way I'm thinking about this is like, okay, we have a task and each task has a type, and you know, like maybe one task is like let's say task 1 is like, okay, I want to you know, rebuild a web template, right? That's like the task. But in this type might be in what we like to call in the programming world an epic, which means that it's like a long spanning project, you know, and that's like one task, but underneath this task are a bunch of like children, you know, or something like that. You know, it might be multiple, but that can get real complicated real fast. So if you want complicated, let me know and I can walk you through it. But if you kind of want to just keep it a little bit more simple, what I'm thinking is a team owns projects, and those projects have tasks, but those tasks can be categorized at will. So let's just put a category here. And maybe those tasks can be in multiple categories. So maybe instead of calling them, which is kind of like the new trend in design, is instead of calling that a category, it's a tag. All right, so we're going to organize our tasks by projects, teams, and tags. So basically a team owns a project. So, and this is where you got to start making some of these decisions. So can a project only be owned by a single team? And for now, I'm going to say the answer is yes. So in this case, I'm going to do this. So a team can have many projects. A project can have many tasks. And then from there, okay, like a tag, you know, and I'm thinking of tags like, it's like, let's say our project is again to rebuild a web template. Let's say the tag is we have like a front end, or let's say we have a tag that's like for menu items. So we have another tag that's for basic CSS, you know, or however we want to divide it. You know, and a task can be assigned to multiple, like, you know, maybe we want to tag multiple tasks in it. So let's do an intermediate table where we say, oh, this is a task tag. And just like we were talked about the Pokemon cards, that's a many to many relationship. So basically, this is going to handle which tasks have which tags, because it can have multiple, right? Like, let's say I want, you know, many. And then over here on this side, we have a team member. And a team member can probably belong to multiple teams. So I guess I'm getting ahead of myself.
No, that's, I was thinking that too.
I am getting ahead of myself. So we have a person over here. So a person can be on multiple teams, and a team can have multiple members.
Yeah.
And then tasks, and again, this is where you got to start thinking like, okay, is each task owned by one person? And I actually like to lean to yes, because the minute you have too many people involved, no one's going to take ownership. So anyways, as far as project management, a person owns a single task. Now, what we could do is we could have another table called like a task contributor. So basically, a task is going to be owned by a single person. So like maybe that column's called responsible person ID or something like that, who's kind of like the main person
In charge.
responsible for that task. Yep, exactly. And a task can have multiple task contributors, though, and a person can be assigned to multiple tasks as a contributor. So this is kind of where I would start, is something like this. And then you can start, like, once you kind of like, because like I'm at 1, 2, 3, 4, 5, 6, 7, you know, which is pretty good. Like, as you kind of flesh out like more things, like maybe, you know, we want, you know, like a task step or like
So,
a goal or something.
yeah, like if you had, let's say you had like, I don't know, like completion dates or something, is that just an attribute? And then we could sort by that, by, okay, what are all the tasks or projects that need to be done in first quarter or something? Or, so is that like is it an attribute that you would then just sort by, or is it another table that you're tracking, you know, a timeline basically or something?
That's a good question. And you could do it either way. So like, if you want to keep it simple, like a basic to do, like thinking of like Microsoft to do or Apple to do list, you know, you just have like a task and a date assigned to it. And in that case, it would just be one little date is an attribute. But let's say that we want to organize our stuff, which is more what I lean to. You know, in the dev world, we call those sprints. So like, let's say you want to let the user kind of define their own like timeframes. So like you said, let's say it's quarterly. So let's say team 1 likes to work on quarterly projects, but team 2 likes to work on monthly projects. They can define their own sprints. And then basically we're going to attach certain tasks in a given sprint. So I'm going to put a sprint task. So a sprint can own multiple tasks. A task can be in multiple. Let me think about that. I think that's right. So a sprint, and actually technically on this one, what I'm thinking is because really a task, and this is, again, I'm making assumptions here. If you want a task to be able to span multiple sprints, You can, but that, in my opinion, is bad form. So what I would say is that a sprint can have multiple tasks assigned to it. So sprint ID would just be in here, if that makes sense.
Yeah.
And then that would connect it to, you know, like quarter one sprint or quarter two sprint or so on and so forth. And then one thing that I'm missing here is I think a sprint should be owned by a team. And again, like this is kind of where you got to make some decisions. And I'm going to say that a team has to define their own sprints. And furthermore, what I think I'm going to do is I'm going to say that each project owns the sprint. So that way, like, let's say the dev team has a couple different projects. They have web, but then they also have like app, right? And let's say they want their app done quarterly, but their app or their web done quarterly, but their app done monthly. So then this project can be set up at like monthly sprints or whatever. And then based on that, like, you know, we can set certain, like this is where you really can start adding tables like crazy. Because let's say that we want to have some like predefined choices like, oh, do you want your sprint to be weekly, monthly, or whatever? So we can like create a table called cadence. And let's say that every sprint is assigned a certain cadence, whether that's quarterly, monthly, and like, let's say you really want to get down to it and you even do weekly sprints. You know, you could do all that kind of fun stuff. And basically it's just like a table to kind of like unify, you know, what type it is. But then from there, you could even go further to say like, oh, if they select a quarterly cadence, I'm going to auto generate their sprints for them. And we can do that with a calendar table. And the calendar table is purely utility. So we won't connect it to anything, if that makes sense.
It does.
And actually we would connect it to something. We'd connect it to here. And basically what I mean by calendar table is really common in databases. One of the first things I always build if I'm designing a new database, whether it's for warehousing or anything else, is I always build a calendar table. And basically what it is it's every date. And usually what I do is I say like, oh, whenever the business was founded, that's day one, or ID one. And then I build every day for like the next 500 years or 200 years or whatever. And then based on every day, I assign it, okay, what quarter is this in? Or let's start the other way. I have the date. I have what week is this in? What cumulative week? Because I want numbers. So like week one would be the week that the business was founded and just counts up 1, 2, 3, 4, 5 based on the week. So that way, if I say, oh, I want to know, you know, how does this week compare to the last 6? You know, it's easy to do that math and not have to worry about dates. So I kind of have that. So weekly, monthly, and quarterly. And for every one of those time periods, I have not only the date. So for example, the original date, I would have the week start date. So if your business says that weeks start on a Monday, like mine does, whatever that Monday date is, I call that the week start date. And then I have a week number, and then I have a cumulative week number. The week number is the month of the week of the year in integer. And then the cumulative is just the total week since the beginning of the business. Then month, same thing, month start date. What was the first day of the month is in date form. What was the month number of the year? So 1 through 12, and then the cumulative month. And then same thing with quarters, if that makes sense.
Mostly.
And I actually might have one here. for us to look at. Let me see if I do. Do you have a screenshot of this? Do you want a screenshot of this? Or
I took a picture of it. So
okay,
yeah, you're
perfect.
good.
Okay, yep. I will delete it and it's gone forever. Let's see if I have a calendar table here. I'm pretty sure I do. Just created one. Let's see. Because if anyone needs like an extra table, these are actually super, super fun to build because you can get real creative about how you go about fabricating them. And they're super, super handy. Let's see, tests. Maybe I don't have the actual file. Let me see if I can pull it. Let me see if I can pull it down real quick. There you are. And apparently it won't let me just export it. So let me see if I'll just take a picture here real quick. I would just show you, but it isn't my data. Screenshot. Okay, somewhere that's saved. Saved somewhere. Let's see if we can get it here. There we go. Okay, let me save this. Sure. There we go. So basically, if you can see that, it is basically I have like a spot date, which is every day. So you can just see that that counts up through the days. And then it shows you what month that's in, the week start date, and then the cumulative month. So this is the first month the business was, not the first month the business was in operation, but the cumulative month and then the cumulative week. Then that way you can, and I don't have quarters in here, but from there you can add quarters and all sorts of fun stuff to kind of, then that way it's super easy to kind of say like, oh, for every, row in this table, I can connect it to based on the spot date. So like if I have a task that's due on, January 3rd, what cumulative month is that in? What's the week start date? You can do all sorts of those kind of metrics to say like, oh, for all the things that are due in week, 104, what's that? So it's a very utility table, which is really nice. But good questions. Any more questions?
I have one that is specific to my project. I don't know if it needs to be shared with everyone.
Okay. Yeah, does anyone else have anything before we disband? Okay, so I will end the recording. Thank you guys for being here, and have a great week. If anything comes up, let me know. I'll stick around. So if you have a question about your project specifically, just hang out and we can talk about it.